All right, so that's 3-4 here. We're talking about estimating a margin of error. So this is the one or two actual numerical sections in this chapter. So when we talk about margin of error, of course, anytime you do any study, right, when you gather results, there has to be some sort of a leeway in your results because everything's not perfect, right? So, this is where we're talking about margin of error. We're going to do what's called confidence intervals in chapter 7. And when we talk about confidence intervals and building it, we have what's called the point estimate and the margin of error. They help build the confidence intervals. So this is in chapter 7. So be aware of that. But we'll introduce it to you now. This course does a good job of introducing things to you and then coming back to them later. Okay, it really does. Okay. All right, so a lot of words here, so let's talk about some things. So again, a margin of error describes how far at most we expect the estimate to vary from the true population value. Remember that we are looking for the true value, right? That's what we want to obtain. But it's hard to obtain that because you can't ask every person in the population. So we get this estimate, right? And again, a margin of error is how far at most the estimate is to vary. And when you think of the word at most, think of plus or minus, right? That could be below or above the true value. Your true value is in the middle. A margin of error goes below and above, creating this interval, right? So when you estimate a margin of error for a proportion resulting from a random sample size of n, to do this, you need to first simulate the distribution of the sample proportion for many random samples of size n, assuming that the true proportion value is equal to the sample proportion from the original sample, blah, blah, blah. It's a lot of stuff. All we're doing is we're simulating. We're doing simulations like you did in section 3.3 with the preferred cookie, right? You got simulations. In that preferred cookie, you assume that there was no difference in cookie brand name versus store name, so there's a 50-50 chance. Well, same thing here. Whatever the sample proportion is, you let that be true for a little while, and you create all these simulated SRSs, okay? And then what you do is you find the standard deviation of those simulations, and you multiply the standard deviation by 2. And when you multiply it by 2, you get the margin of error, okay? And that's our estimate for the margin of error, okay? Okay, so note, it is common for the media to report the margin of error of an estimate in the fine print, right? So again, no one wants to admit how much they're off by, so they put the big estimate really big, and then in the margin of error they talk about in the margin or the fine print they talk about their margin of error. So for example, we might say the margin of error is 2.6 percentage points or 0.42 plus or minus 0.026. So remember, when we talk about proportions and percentages are essentially the same thing. So this right here is in terms of proportions. There are no percentages, and again, they're decimal values, right? This is a proportions. So if I were to take the same situation and make percentages, it would be 42% plus or minus 2.6%. So that would be using percentages. And again, when I talked about confidence intervals, what would the confidence interval be for this situation? Well, to get the confidence interval, you would simply take 0.42 and subtract 0.026. So when you do that, you get 0.42 minus 0.026, 0.394. So 0.3942, and to get the upper bound or upper level, you would then add 0.42 and 0.026, and you would get 0.446. So that would be where we think the true value falls in this interval, okay? And again, that would be like 39.4% to 44.6% if you want percentages. So that's how this stuff is all related. But again, our goal today is let's calculate this margin of error, okay, and interpret it. Okay, so example 1, it says, do people approve of the president's job performance? In March 2014, the Gallup polling organization surveyed a random sample of 1,500 U.S. adults. Overall, 42% of the people in the sample approved of the way Barack Obama was handling his job as president. The dot plot shows the proportion who approved of the president's job performance in each of 300 random samples of size 1,500 from a population where 42% of 40% approved of his job performance. So let's talk, okay? So we obtained one random sample of 1,500 U.S. adults. 42% said they approved. This is our sample proportion. Sample proportion. Now, we'll talk about this later on in the year, but that means that's our p hat value, sample proportion, and that's p hat. Just like y hat is our predicted y value, p hat is our sample proportion value. So this is where we get a whole bunch of simulations. 300 SRSs, simulated or simple random samples, and we do have of size 1,500 from a population where 42% approved of the job performance. And again, this is assuming that the sample is true, that our sample value is true. So we get this simulated distribution, okay? So it says, use the results of the simulation to approximate the margin of error for the Gallup's estimate of the proportion of U.S. adults who approved of President Obama's job performance in March 2014. So to find the margin of error, we are going to take 2 times the standard deviation, and the standard deviation is right here, 0.013. And when you do that, that is 0.026. There is your margin of error. That is a proportion, so it has no units. If you move the decimal 2 places to the right, that'd be 2.6%, and that would have percentages as its units. Okay, now part B says interpret the margin of error. So again, we can't skip these interpret questions. So we are going to say we expect the true. So this is important. The true, right? That's what we want. We want to find the true. The true proportion of all U.S. adults. So again, sample versus population, right? Of all U.S. adults. And then what are we measuring? Who approved? So this is a lot of it's restating part A. Who approved of President Obama's job performance in March 2014 to be at most, and this is the important margin of error, to be at most. And then we put the margin of error 0.026 from the estimate of, and 0.42 is our estimate. Notice I write it in a proportion, not a percentage. And that is your interpretation. We expect the true proportion of all U.S. adults who approved of President Obama's job performance in March 2014 to be at most 0.026 from the estimate of 0.42. All right, so that was a proportions problem. Next is a means problem in the next video.